which is the main jobs of the constructor. So constructor is, first job is to create an object in memory. So it goes and it reserves a spot in memory for your object's data. So in the square we had a width and a height maybe and an x and a y. So it would go out in the memory and it would reserve that space up in memory, and then it would initialize the object's instance variables. Those are the two main jobs of constructor: to go and reserve that spot in memory and to initialize. What does initialize mean? I keep forgetting I don't speak English sometimes, so. Initialize means just set an initial value for it. You wouldn't set an x and y location of -1 and -2. Perhaps that doesn't make a lot of sense. Or maybe a width of -1. What does that mean? That's not sane. You don't have a square that has a width of -1. So one of the jobs of the constructors is to set that initial number for the instance variables so that they make sense. You want your object to start out in a sane state. You don't want it to be insane. I have a width of -5 million and a height of 2.7 billion, something that's really ridiculous. You want to set it to an initial value. That makes sense. So again, main jobs for constructor: first you create the object in memory, reserve that location in memory for the data, and then go into that data and initialize it to something that makes sense. Now there's something called a default constructor. So I'm going to open up the compiler. I think this is better set inside the compiler, so let me start this up. So here I'm making a square class. That's kind of what we've been using so far, so we'll use that. Now our square class has some private instance variables, width, height, maybe an x and a y. So again, these are instance variables. And the idea with instance variables is you want to keep them private. We talked about accessors and mutators. The way you can create accessors and mutators inside NetBeans is that you can just say refactor, and you say encapsulate fields. Instance variables are sometimes called fields, so that's why they use that terminology. And notice we can create get and set functions for each of the different instance variables we have. So those are the 4 instance variables. If I say refactor, suddenly I have all my get and set functions. Really nice. You don't have to type them in. Going back to our review then. So this first one, let's just go back and I'll do this in code. Know how to call a constructor to create a new object. Again, if you remember what I said earlier, I would say in my test class, I would say square, my square, equals new square, and I'd pass in the x and y, and then the width and the height. Okay? So what's the job of the constructor? We said that it's to allocate memory to reserve for the data of the object and also to initialize the variables. So there's a special type of constructor. It's called a default constructor. So let me specify that now. Say public, then you put the class name. So the class name and the constructor name are the same thing. A default constructor is a constructor that has no parameters, okay? So that's the main difference. Has no parameters, but you still need to initialize all the instance variables. So we would say width equal, let's say 0. These seem like good initial. If they don't take the time to specify what these parameters should be or these instance variables should be, you just want to set it to some default state. That's why it's called a default constructor. But typically you want to create a square that is a little bit more meaningful. So we would provide a second constructor, But this time we're going to pass in the x-coordinate, the y-coordinate, the width, and the height. And this time we would use the parameters that they sent in to initialize the variables. So both constructors initialize the instance variable, but this one's a little bit more specific. Here we would have to say this dot x is x. The reason why I have to say this is because the x here and the x down here have the same name. So you have to be a little bit more clear about which x you're talking about. What you're saying here is grab the x that's coming into the constructor and put it inside this object's x variable. Same thing with y. This dot y. You would say y. So this is not a default constructor. This is just a standard constructor. What differentiates a default constructor with a regular constructor? And the answer is a default constructor does not take any parameters. It doesn't take any parameters. See how the in between the parentheses, that's empty? Okay. So that's a default, that's a regular one. Okay, so we looked at this, how to call a constructor. So we're going back to our code in the test class. See, now it's happy because I provided a constructor that takes 4 integers. There's the x, y, width, and height. So that's how you call a constructor. That would be number 1 on our list. Know where method parameters should be placed when calling a method. And just to review again, since I didn't get it recorded. It just goes right in between the parentheses. So those are called method parameters. Actually, from this point of view, it's called an argument, but if you actually are inside the square class, these are called parameters. Okay? Arguments are what satisfy the parameters. So the arguments are here. Those satisfy the parameters that are here. Know that instance variables belong to the object. We go back here. Our instance variables are width, height, x, and y, and notice they're private. You can't get to them directly from the outside. And they belong to the object. Each object will have its own width, height, x, and y. If you have multiple squares in your program. Okay, so up here, if we had a second square, we could say square my second square. And it can have its own different numbers for the parameters. So the instance variables in this square would be different, have different values than the instance variables in this square. I think that illustrates it pretty well. You know the purpose of an accessor method? Well, our accessor method, the purpose of it is to go get the value of a private instance variable. So say we want to get the width. Here's the accessor for that, get width, and all it does is return the private width. Know what the typical access specifier is for an instance variable? The accessor method is just to get the value of a private instance variable. So say we want to get the width for our square. We can't get it directly because notice it's labeled as private right there. So the purpose of an accessor method is to get the value of the private instance variable. We want to get the width, but we can't get it directly. We have to go through this getWidth method. The accessor gives you the ability to go and get that value. If that wasn't there, you couldn't get access to the width because it's private. So you need to have that accessor in place. Now the typical access specifier for an instance variable, here's our instance variable. The access specifier is private or public. Those are the 2 words. For instance variables, they're almost always private. That's the way you should do them. You want to have code from the outside to always go through accessors and mutators. You don't want to let code from the outside get direct access to the data. So for instance variables, always make those private, just by convention. Here, number 6, know that methods can return a value or return void. And we saw that in our class. For the accessors, they return a value. See the word int right there? That's the return type. This is the kind of number you'll get back. Set methods or mutators don't return a value, so you have to put the word void in there. But they do change the value. See how it's changing the width of this object to the width that's coming in as a parameter. So it either returns a number, or it has a return value, or it returns void. Void means it doesn't return anything. Number 7, know that methods can be public or private. Our accessors and mutators are all public, right? But sometimes you want a private method that you only want other methods in your class to call. So you would say private void. I think I used a variable called smaller. And say perhaps in here I say, so say I just want to make the square half as wide and half as tall. So that'll take my my square and make it smaller. Okay? I don't want this to be available from the outside, so I put a private access specifier on it. So only other methods in our square class can call it. Objects from the outside of the class, it's like this isn't even there. They can't call it directly. If I'm here in the testing class and I want to call that on my square, I would say my square dot smaller. It won't let me do that because it'll tell me, hey, smaller is private. You can't call it from the outside. If you want to be able to call it from the outside, you have to go in here and change that to public. And now when we go back here to this code, you see that that's okay because now it's public. Okay? So that's the difference between a private method and a public method. Note that objects are the nouns and methods are the verbs. Well, then in our example, our object is called my square. That's a noun, right? And our method would be a verb. So you would say, maybe call this one make smaller. That's more of a verb. That would sound better. So maybe I change this to make smaller. So our object name then is my square, that's our noun, dot, and then our method name, which is a verb. And that helps differentiate between an object and a method. Okay, so number 11, note the coding style guidelines used by most Java programmers when naming classes. Classes are always start with a capital letter. If there's more than one word in the name of the class, then start the next word with a capital letter. And you want to use camel case in that case. So the only thing that should start with a capital letter and use camel case is a class name. Notice that the objects that I create, my square, see how it doesn't start with a capital letter? So that's how you tell the difference between an object and a class. Class names start with a capital letter. Objects names start with a lowercase letter. Right, number 12, know that constructor names and class names must match. So looking into our class again, here's our class name. Notice it matches exactly the constructor name. Class square is here. Here's the same name. Here's the next constructor, same name. All of those three have the same name. The class name and the constructor name are always the same. Okay, let's look at number 12. Here's a weird thing about Java, and this is only in Java that I've noticed, is that the class name and the actual files where those classes reside in, those names must match as well, which is really strange. So let me show you what happens. Say if I decide to change my file name to, say I change this to big square, that's the name of the file. It sees that you just changed the name of it over here. Do you want to change the name of the class inside here? And if you want to do that, you'd say refactor. And watch what happens when we do that. Now the class name for the source file has big square in it, and everywhere where there's a class name, that got changed as well. Even in here, see how all the squares changed to big squares? If I want to change it back to square, I go over here and change the file name. It's just weird. Changing it back, hit enter, refactor, and now all the squares are back. So this file name and this class name needs to match in Java. It's the only language that does that I've ever seen. Know that access specifiers can be public or private. Well, we already learned that. When writing a new class, know the order I recommend for laying out the parts of the class. First thing you do is you put the constructors then the methods, then the accessors and mutators, and then the private instance variables. How would I change our square to kind of match that up? Well, first is the constructors. That's the first two things in my class. I tend to like to put these instance variables all the way at the bottom. So I'm going to put them right here. Next, I put in the methods that are not accessors or mutators. Maybe I put those in next. So I'd put those right here. And then all my accessors and mutators. And then finally the instance variables. Since these are private, it's a good idea to put them last because you don't want people messing with them anyway. So again, the order would be the constructors, any methods, then the accessors and mutators, and then the instance variables at the bottom. And that's everything you need to know for Chapter 3. Okay? So what I'll do is I'll edit this video and then I'll put this out on YouTube, and then when you want to review it for the test, you can take another listen to it. If I went by too fast. Is there any questions on that before we move on to the next one?